Hello and welcome to this Coevolve webinar, where we'll talk about how you can build a roadmap to reach the next generation WAN. My name is Kieran Roach. I'm the CTO and one of the co-founders of Coevolve. I'll be joined on today's presentation by our CEO and co-founder, Tim Sullivan, who will speak to some of the commercial benefits of this type of solution. A little bit of background about myself. I'm based in Chicago in the US, and we together started the Coevolve business almost a year and a half ago with the intent of helping to bring agility and a new approach to the wide area networks of multinational enterprises. Prior to that, I held a number of technical roles in global network service providers and consulting firms, but all of my career helping multinational enterprises address networking challenges and adopt new technologies in a well thought out, seamless way. And a lot of that experience included a background in broadband technologies, the use of internet in an enterprise environment, and so on. As I mentioned, I'll be joined by Tim Sullivan. Tim is based out of Sydney, Australia, and his prior experience included many years across a range of roles in network service providers and other similar roles, but across that entire period, completely focused on that multinational enterprise segment, managing teams to help deliver high quality outcomes to those types of enterprises, with a very strong focus on getting the right contractual frameworks in place and a strong SLA structure then to be able to support those agreements and to deliver that positive outcome for the enterprises. What we'll cover today, we'll give a very brief introduction about the Coevolve business. Then we'll move on to talk about some of the issues that we see with WAN solutions today. And I think many of the points we mentioned here will resonate with really anybody who's involved in delivering or supporting network solutions for multinational enterprises. What we'll talk about then is the potential of a technology called software-defined WAN as a possible way out of some of these problems, and something that we believe can become the foundation for the next generation, the next iteration of this wide area network. And many of the concepts that we'll talk about can be applied to many different industry sectors and many different network types. We'll talk about one of the major challenges that comes out of that type of solution, which is a whole new set of vendor management challenges and activities that need to be thought out. And we've got a well-governed approach there for dealing with that we'll speak about some of the benefits of. And then we'll pull all of that together at the end to talk about, as the title suggested, how you can turn this into a viable roadmap for the business. So if you're planning to go down this path, or if some of the potential benefits of this type of technology are interesting, what can be done to get from point A to point B and adopt these technologies and realize many of the benefits of those. So with that, I'll pass over to Tim Sullivan, who will give a brief overview of the Coevolve business before we get into the detailed parts of the session. Tim?
Thanks very much, Kieran, and really appreciate you all logging in today for this webinar. By all means, fire those questions across to us. So to give a quick background on Coevolve, we are a purpose-built networking specialist that provides both professional services and managed services. We very much see that IT, the rest of IT, has moved so quickly into an as-a-service and agile domain in this very dynamic business and IT world. However, by comparison, we still see a lot of network services moving very slowly, and we're starting to see that the global wide area network is often a real drag on a lot of these key cloud and other initiatives that the business is wanting to roll out, and critically ensure that there's a really high quality user experience around that. We are hearing that feedback from a lot of industry analysts like Gartner. Most critically, we hear it directly from the clients that we're talking to. So in terms of our client focus, we really look for those enterprise clients that have got a business critical environment and they've got a wide geographic spread of those users across that network. So you can see a number of the verticals that we specialize in there, but another hallmark of those businesses is that they need to adapt very quickly to a lot of change going on in their industry, a lot of change demanded by those end users. And we've built this business up with a fantastic team of really experienced networking specialists who bring decades of experience, but from a variety of different angles. We've had some of the team work in the very large global service providers, regional carriers, integrators, various management consultants and vendor analyst type organisations. So there's a real breadth of experience that we bring to bear for our clients. And we've got that team of experts spread globally. We have offices in the 4 countries you can see there, Australia, the US, Singapore, and a fantastic response centre in Kuala Lumpur, providing incident and change management around the services that we provide to those global enterprise clients. But we've got much further contact via a very extensive global contractor network right across the world, so that we can very dynamically respond to requirements anywhere around the world. And you can see the practice areas that we focus on there on the right of the screen. Today's topic will talk to the network orchestration and the vendor management practice areas, but inevitably there's any number of those other areas that impact on the performance of the network. So we have great specialised services and capabilities and depth of knowledge that we bring to bear for our enterprise clients in all of those supporting areas as well. Thanks, Kieran.
Great, thank you, Tim, for that. So now let's move on to talk about some of the problems that we see with wide area network solutions today. And probably the single biggest change that we've seen across the demands that are there for enterprise networks is that the destination of the traffic is changing very, very rapidly across almost all enterprise networks. And that's primarily being driven by a very rapid adoption of public cloud services and the overall rising importance of just general internet destined traffic within these networks. And those of us that have been in the industry for more than the last 5 or 6 years will remember very clearly a time where the wide area network was a closed network. The traffic stayed within that network, the applications were within that network, and perhaps there were a handful of breakout points to the internet for certain users that were authorized to do that. That type of design is just no longer viable for any enterprise that's operating with a modern set of applications. And our data shows easily 70 to 80% of MPLS traffic that's carried over enterprise WANs is destined for somewhere off that network. So whether that's critical public cloud traffic, whether it's web browsing, which can be a combination of critical and non-critical, but the reality is that private network, that expensive private network, is being used to carry this traffic just to take it somewhere else and leave that network. And that's a major inefficiency in many of these networks. We're seeing a huge increase, to take just one example of a public cloud application, across our customer and prospect base. At least 75% of those businesses, tens of thousands of users, are rolling out Office 365 to replace existing in-house Exchange or Notes environments. And we're seeing that pace accelerate month on month. More and more pilots are being done, proof of concepts, and then whole-scale migrations across entire enterprises are being done to this type of application. And if you repeat that across all of these other applications that are in the mix, you start to see a very dramatic shift in those traffic patterns. And that's only part of it. That's at the application end of the spectrum. We're seeing more innovative IT departments now starting to look at all of the underlying infrastructure that sits within their organizations, the servers that run DNS and DHCP and basic administrative functions within the business. They're realizing that these can be very effectively dropped out into Microsoft Azure or Amazon Web Services, and the economies that they can gain from that allow them to fund other areas of innovation within the business. So again, big portions of that traffic changing so that they're now destined for somewhere off that private network. And then you've got the non-IT decisions that are a real wild card in this mix and can make it very hard to predict, where you've got at a business unit level, they'll make a decision to roll out a new HR system or CRM system for the sales team. And overnight, you can have a situation where hundreds or even thousands of users now have a new critical application they need to access. and nobody has forecasted and planned the impacts of that on the traffic flows on the network, and all of the carefully balanced QoS schemes go out the window when you start adding in this significant volume of traffic. So it's a pretty bleak picture if you've had that comfortable environment where the network used to behave in a very predictable way. Overnight, you're starting to see, right from the base infrastructure all the way up to the applications, a very significant shift in where those pieces of infrastructure reside. And that puts a whole new set of demands on that traditional wide area network. That leads to a whole new set of problems in terms of additional bandwidth requirements, the need to be able to scale up and down bandwidth to meet demand, the importance of the network even at many locations. There's locations that in the past might have been able to survive for a day if their network connection was down. If you've moved most of their infrastructure and applications to somewhere beyond that physical location into the public cloud or elsewhere, all of a sudden you've got a very significant challenge there that needs to be addressed. And what does that look like within the WAN? Well, at the same time, the WAN quite simply just hasn't kept up. We've seen agility creep into almost all other aspects of IT, and the WAN just has not seen those types of flexible options, short-term contracts, very agile processes and business models that you've seen elsewhere. You've got high capex involved in almost everything, expensive equipment, expensive implementation fees for circuits and WAN optimization services and so on. You've got a very inefficient system where, without a lot of highly engineered solutions, you've got half the capacity on the network wasted because backup circuits just sit idle. You don't easily have a flexible framework to which you can add mobile, satellite, other alternative types of connectivity. The solutions that do exist for manipulating the traffic flows are pretty primitive. They're based on different route availability and so on. You can't very easily drill down into a particular application and say you want to take path A instead of path B. And the bandwidth demands really can't be underestimated on traditional private MPLS networks. These are capacity constrained networks that you don't have the luxury of planning for twice or three times the amount of capacity you need today. In most cases, it's added on a just-in-time basis. And that's particularly true if you operate in high-cost areas of the world, like the Middle East or Africa or South America, for example, where the capacity is just so scarce on these private networks that you really have to just take the absolute minimum that you can get by with. And as we've talked about, these new traffic flows are turning these networks inside out. They're now being used as this transport mechanism to deliver traffic outside of that network. And to make this work, you've got a lot of highly complex device level configurations, a lot of human error, a lot of very difficult to transfer the knowledge around these types of networks, even if it is within the organization. Just keeping the documentation up to date and being able to articulate clearly what's going on to a person who's not familiar with the network can be a major challenge. And then from a more strategic perspective, in the traditional WAN space, there's just no real concept of adding services into the network as a concept. You can't easily say, I want to add this function to the network and it gets applied everywhere. It's every device being configured separately and being tested in its own right to make sure that it has the required level of functionality. And that's just not a viable approach for most enterprises anymore. So what we see, and we're seeing this reflected in the analyst community, and you see a Gartner comment here which sums it up quite neatly, the network and the WAN in particular really is an obstacle to this agility that is being demanded by everywhere else in the IT environment. So the main thing we want to talk about today is a potential solution to many of these issues. And we'll talk today about a technology primarily called software-defined WAN, which we abbreviate to SD-WAN. And this is really an evolution of a lot of concepts that have existed in networking for quite some time. So the whole concept of software-defined networking it arrived in the data center and core LAN environments several years ago, and it's changed the whole approach there to designing these high capacity, low latency networks, where in the past you had devices that were self-contained. They had the control plane, which is the decision-making engine around where traffic needs to go and what needs to happen to each packet, built into that same device as the pieces of plumbing that were carrying the data itself, the data plane within those devices. And if you wanted to configure a network in the past, you configured lots of instances of those devices across the network, and each of them behaved relatively autonomously with only the bare minimum amount of cooperation between them in the form of routing protocols and so on. So that's one concept that has started to become very outdated. What's replaced it is the concept of separating that control plane from the data plane and pulling that intelligence around making decisions in the network and what traffic should go where out to a separate point in the network, which is generally called an orchestration system, where you can make decisions by looking down across that whole network and being aware of all of the different components as opposed to a device just being aware of itself. So that's one significant change there, where all of that intelligence gets moved to a separate software platform. The second is the concept of virtualizing particular functions in the network. And let's take a really simple example here, which is a firewall in the network. This is traditionally a box that you could point to with Ethernet interfaces and its own power supply, and it's sat there, next to the switches and routers in the data centers, for example. But if you think about the function it's providing, that is something that's all running in software on that device. And what we're starting to see is a real interest in scrapping that separate piece of hardware for that particular function and instead providing a virtualized firewall service across the whole wide area network. And when you start to combine these technologies, you see a lot of efficiencies that can be gained. You can have a lot more repeatability. You can have a lot more scale that can be introduced into the solution. So in the next generation WAN, we see a lot of these techniques being adopted, but what we see on top of that, and this is primarily driven by the rapid rise of public cloud-based technologies, is a goal where you can use more internet-based infrastructure and build these networks using software-defined networking techniques and leveraging the price points around some of this low-cost internet-based infrastructure, and having, in some cases, a hybrid environment where more of the network sits on local internet connectivity and some of it sits on MPLS connectivity. In some environments, it's even further than that. We've seen many enterprise environments now where the entire network can be delivered effectively over internet-based technology. So the potential that this opens up is for a great new range of functionality that can be brought into the wide area network, and in a much more flexible way than you previously had with device level configurations. And it's a relatively new space, but there's some vendors in this space that have had technology solutions for coming up to 7 or 8 years now, and it's really only in the past 12 to 24 months that we've really started to see a very rapid rise in the interest in taking this from a useful theoretical approach to something that can be a viable solution to replace a portion or the majority of some existing infrastructure in a network environment. So we mentioned some of the vendors here. We keep on top of this space on a daily basis. Our team around the world is very well versed in terms of the pros and cons of different solutions, where they fit, what types of solutions are an ideal fit for what type of existing environment. And that's some of the value that we add as we start to have these conversations about building roadmaps, is helping to understand what could be used where as you adopt these technologies. So let's take a quick look at what this type of technology can look like. And you're probably familiar with what the traditional network, wide area network looks like, and it's almost always a private IP-based network, typically MPLS, perhaps some breakouts to the internet at certain points on the network. But what we're seeing here is an evolution towards this type of hybrid approach, where you have multiple links going into a location, and they can be internet, they can be MPLS, they can be fixed, they can be wireless. There's a whole range of options there that you can have for these types of connectivity. But what you're doing then is having all of the intelligence around what those links are being used for pulled back up to that central orchestrator where you have centrally controlled business policies, you manage the services at a network-wide level, and then you get all of the reporting and analytics on what's going on with these devices. So you've now got a very visible dashboard in terms of what's happening on that network, where you have issues, where you need to focus, and so on. And what we're able to do with this type of solution is be very, very selective about which paths are being taken for which traffic types on the network. So if the traffic is going to an in-house application and it's a critical application, it's not particularly bandwidth hungry, then perhaps if there's a private path available, then that's the one we would select for that. If the traffic is going to a public cloud application, there's a much more efficient way to take that traffic by sending it out through a series of cloud gateways, which are part of many of these solutions, where you can optimize that traffic all the way back to a point where it essentially touches that cloud service provider, and you're able to get a high level of performance back to a point very close to those applications. And then if you're breaking out to the internet, you'd like ideally the ability to do that on a local basis with all of the assurance that you'd expect around a consistent firewall policy and rules being applied in a seamless way across that environment. So it's this type of topology, with or without that MPLS component, that we really starting to see the enterprises moving towards. And the primary reason we're seeing enterprises looking to adopt this type of technology is the fact that they're seeing their existing networks not be fit for purpose in terms of that application and performance demands that exist out there. But one of the key benefits that we're able to deliver as part of this solution is a significant TCO benefit in many cases. So it's not uncommon at all for us to see, with this type of an approach, with more efficient use of links and more efficient and more widespread use of local ISP broadband connectivity, to see 50% or more savings in the course of implementing the technology across that network. And this is an anonymized extract from a piece of work that we did earlier this year, where we looked at all of the costs that will be incurred from a network perspective for staying with the current provider and negotiating a bit with them to get the rates down. But on a bandwidth constrained MPLS network, you're back up to your original price points and higher very quickly, because you have to keep adding bandwidth to keep up with demand. With the next generation solution, with all of the extra bandwidth that's available and the ability to use all of the links at each of the locations, you're able to achieve very quickly a cost benefit, but then you benefit even further as you add more capacity into that network, where your rates improve and the bandwidth prices for those internet solutions continues to drop. So this is an area that we've modeled for many enterprises now in a lot of detail, so we can really start to articulate where the TCO benefits come from. And they're almost all driven by the efficiencies of this type of network and the agility that comes with that, and the dramatic improvements that we can see in the underlying cost of the connectivity and how much is actually usable within the wide area network. From a technical perspective, we see a significant level of functionality that can be added using this type of solution. So we work, as I said, with a range of different vendors, and we've taken some of the functionality benefits of one of those types of technologies as a representative example here, because I think it gives some good insights. But some of the key additions to the functionality that you get are things like the ability to have multi-path routing from a particular site with a very dynamic approach to that. So on a packet by packet basis, determining, should I send this traffic down link A, B, or C, or if it's really critical traffic and the link quality is poor, then perhaps I'm doing things like forward error correction and sending that traffic down both links to make sure that I'm maximizing the chances of getting there at the other end. So all of these decisions can be taken at a much more abstracted level than you would have in a traditional network, where you'd be dealing with access lists and configuration to determine what's happening to what traffic. The ability to determine all of this at a policy level and then have the intelligence within that central platform used to dictate what should be done on each of the edge devices is a significant step forward. The other key areas, things like smart quality of service. So the ability, as soon as you start to pass traffic over this type of network, to analyze it and to tag all of the different types of traffic based on a profile matching technology that can allow you to see very easily what this traffic is. It's not just Office 365, it's SharePoint traffic within Office 365, or it's this particular element of a complex unified communication system, and you can separate the control traffic from the RTP streams and things like that. So these are pieces of functionality that may have been possible in traditional networks, but almost always through the use of bolt-on components and analyzers and collectors and so on to get this type of data. So being able to do it as part of a bundled system is a very new approach. And even more so is this whole concept of a business policy, a business-driven policy for making decisions on the network, where a non-technical person can say, this application is important, this one is not so important, here's what SLA I expect to get for these applications. And then the network just figures out what's needed to be done to make that happen. That abstraction of the two concepts is, again, just something that didn't exist in traditional networks. And then finally, the ability to get very relevant and useful dashboards to mark, you've marked all the traffic depending on what application it is, to be able to see that by user or by site and by time of day, all of the different views that you may want to see around what's happening with your applications and how are they performing, when do they meet their SLA, when do they fall below their SLA. All of that now is an out-of-the-box piece of functionality that can be achieved using this type of solution. And then there's a whole level of ongoing technical benefits beyond that. We've taken some screenshots here from a technology solution from VeloCloud that we work with very closely for this type of solution, because it really does represent some of the completely new ways of thinking here. If I won't go into all of these, but if you look at the diagram on the bottom right, what you're seeing there is the bottom two bars are the measured quality of two links into a particular site over a period of time, where you had packet loss, you had links dropping out, you had variations in round trip delay times. And what you see across the top of that then is the virtualized network path that has been delivered by combining the best of both of those connections. So this is a level of insight that just doesn't exist in those traditional networks, where you're able to take a piece of data back to the business and say, here is the service that you got at these locations. And we're able to get it using these two links. We're perhaps getting average quality out of one of them, and the other one was pretty good. But when they were combined, here's what you got in terms of a user experience for Oracle or for SAP or another critical application that's running at that site. So it's empowering the IT department to have far more constructive conversations that are data-driven, rather than just treating it on a subjective basis, which was the traditional approach in the past. So it's fair to say that software-defined networking solves many problems. There's no question that it provides a foundation for a more agile network, a more elastic network. You get far better visibility of what's going on, and it's most definitely a much more cloud-ready solution. The reality, though, is that it imposes a significant vendor management headache. And what we find is that most SD-WAN solutions really are at their best when you're using a lot of local ISP connectivity. So putting in two local ISP broadband connections into a site, for example, will give you some of the best technical functionality, but it now means that you've got all of these extra ISPs to manage across the network. So we'll spend a moment just talking about how we address this challenge and how we can help improve a whole new problem there that many enterprises are facing. So our approach here, we've built, as we said from the very beginning, we've built this business around helping enterprises adopt these next generation technologies. And part of that is making sure that they can manage and support that environment and the vendors that are involved in it effectively. So what we've built, and we've had this from the outset of our business, is a real strong competency around the life cycle management of third-party providers, and particularly ISPs and locally contracted services. So our approach to this type of service is that the services can be bought locally at the best price points with a degree of governance around what products to buy, what ISPs to focus on or avoid. So a lot of assistance and steering in terms of who to use in each market. And what we provide across the top of that is a single point of contact, a single operational and commercial management interface across each of those ISPs. So we sign letter of agencies with the providers. We provide the single interface back to the client, and on a day-to-day basis, we perform the management of those underlying vendors. So if there's a fault on the circuit, we take the responsibility for raising the ticket with the provider and managing that through to resolution with that provider. So the client sees this as a single point of contact. They see it as though they were interacting with that single MPLS vendor, for example, but they're retaining the commercial attractiveness of these underlying providers. That's often the reason they selected them in the first place. So there's a lot of detail behind this, but the basic principle here is to remove all of that complexity for the enterprise of dealing with these many different underlying providers. So the obvious question, and really what we wanted to make sure you take away from today's session is how do you get there? How do you build a roadmap to get to this type of technology? So We've worked out a lot of methodologies for this, and we've helped a lot of enterprises adopt this type of technology already. But the most important place to start with this type of an approach is really to understand what you're trying to achieve from the project. So it all starts with identifying internal sponsors and champions for this type of a project, and getting feedback early on. So talk to industry peers, talk to references that the technology vendors can provide and so on, to learn about what they saw, what was good, what was bad, and so on. But most importantly, from the very beginning, set those high-level goals. Are you trying to achieve savings? If so, what's your goal? How much are you trying to achieve from the project? Are you trying to improve one particular application because there are so many complaints because of it? So having that clear goal will help drive what you do next with the technology in terms of turning that into an end-to-end solution for the business. And then start to very quickly look at parts of the environment that could be a good place to trial the solution, and whether they're friendly users or sites that are easily accessible. There's a range of different factors that could be taken into account there. And then if you're going to trial or proof of concept the solution, identify what your expectations are, what your timelines are for doing that trial, and so on. Then you really have to understand at a detail level where this technology is going to fit in. So what applications, users, locations are experiencing problems today, or are capacity constrained, or could benefit from some improvement. What's the priority of these different applications? It's a granular question that many enterprises haven't had to think about before, because they didn't have a network that could treat their traffic in such a granular way and help to prioritize traffic in that way. Understanding your limitations and flexibilities around existing supplier contracts is key. So if there's an existing managed service, can this coexist with it? Do you build around the outside of it so you only focus on the out of contract pieces? What's in place in terms of connectivity? How long does it have left? Can you keep it in the solution, and so on? So there's a lot of detail to understand as you start to map that out. What's upcoming in terms of CapEx investments? This is a major factor in building TCO models. If you stay in the as-is mode, what are you going to incur in the next 36 months, for example, on new routers, new firewalls, new WAN appliances, and so on? And then this is a particularly good time to get network diagrams and the overall architecture refreshed in terms of the documentation around that, so people are completely clear about what they're migrating from. It's far easier to do the migration if you've got that clear reference point at the beginning to know what's in the environment. Then it's the preparation for transition. So revising the business case and the TCO models, the site-by-site technical design, putting sites into different classifications for templating purposes and so on, and then building the roadmap to perform the implementation that's really aligned with the overall goals of the project. Documenting the approach with a strategy document, and then we find is a major factor in the success of these types of projects is getting the right communications plan in place so that you're able to involve the stakeholders across the business and they're not surprised by a complete change in direction from a technology perspective perhaps, but it's a decision that they buy into and they see the benefits of from the very beginning. And then finally, the implementation of this type of solution. And this is a really key point, that you're not dealing with a traditional WAN procurement approach here. So this isn't a type of technology that you go out and procure on a 3 or a 5 year cycle with connectivity and management and all of those other aspects bundled in. It's an approach that you can take a much shorter term view on. Really looking at a 24-month contract and maybe stretching to a 36 months for certain aspects of it. We would advise even shorter terms for the underlying connectivity to leverage the falling prices we're seeing for internet connectivity around the world. And understanding what the internal team is responsible for as you go through this type of an approach. So the ability to get away from these device level configurations and day-to-day complexity means that IT department can start to focus on more strategic initiatives and adding value into the business, as opposed to just being in a firefighting mode on a permanent basis. And then that type of phased migration approach that we definitely recommend means that you can not have big spikes in cost where you're doubling up on a service on top of an existing contract. You can phase in the migration of this type of technology around the phasing out of existing services as their contracts come up for renewal. So with that, I'm going to do a couple of things. I'm going to pause for a moment and hand over to Tim to just wrap up the summary in terms of our approach here and to talk about how we can help. And then I'll collect questions. I've noticed as I speak here, there's a few questions that have come up from the audience. If you have any, please send them in now through the chat function. And then after Tim concludes our portion of the presentation, I'll address those questions that have come up and we'll wrap up the session after that. So Tim, over to you.
Thanks. So as Kieran's outlined, there's lots of opportunity in this space to dramatically reduce the total cost of ownership, to get a fundamentally better operational experience and ease of use, and to fundamentally increase and improve the end user experience. But we've all been around technology a long time, and there's always a lot of issues to meet head on, and we all know that the devil's in the detail. So our team is here to provide really quality help to get underneath all of the vendor hype. So our differentiator is that we really act as the bridge from the existing environment and legacy technologies to these new technologies. We deeply understand the environment, having been around those technologies for the last couple of decades, and we're very close to all of these new disruptive technologies and vendors. We look at it very much from a life cycle perspective and carefully assess the timing and the phasing of that. So we can help you and your team assess your network and application environment. We can help benchmark from a technical as well as a commercial perspective. We can look at how to help you re-architect and what is the roadmap that your business needs and that's right for your individual circumstances. And what's the right vendor management wraparound that, as Kieran said, this technology does highlight some issues in that space, all to ensure that your entire application environment works well and what are the associated applications that need to perform really well over this environment, such as unified comms. So our team is ready, willing and able globally to interact with you. So we'd love to exchange views and address various questions that you and your team have at any stage. Kieran, I see one question's come through in terms of what type of sites do you think should enterprise clients consider for a proof of concept for this SD-WAN technology?
Yeah, thanks for that, Tim. So it's a good question, and it's one that probably depends on the type of business. So we would always advise making sure that these sites are going to be representative of what you're going to see elsewhere in the environment. So it's very easy to just select the site with the best quality connectivity that's a couple of kilometers from the head office and the central IT department, but that may not be representative of the type of actual performance you're going to get out in the field and the challenges that come with that. So we'd recommend somewhere where perhaps you've had some problems in the past, you've had connectivity challenges, you've had stability problems, you've got ideally a flexible and cooperative group of users or management team within that location so that they will be supportive of some disruption as you go through a piloting process and use them as guinea pigs a little bit to help understand the process they're going through. So definitely finding that balance between something that's manageable and something that's going to be representative of the environment. A perfect example we see is that in many retail clients that we work with, for example, they've got mock stores or test stores built, which include a range of different connectivity types and LAN infrastructure and so on. And we're often able to plug into that type of an environment where they have mechanisms to introduce failures into the environment and to pull out links very easily in that type of controlled environment, but still have all of the actual applications there. So that's one sector where we see that type of approach already being thought out because the LAN side infrastructure and appliances and so on are so critical for them to get right. They've built these test sites in advance. But we can certainly help identify the right locations, help qualify what you might see in advance as you start to look at the locations on the network. So that's an area that we see us ourselves getting involved in right from the outset in terms of these decisions for choosing which sites to do a pilot or proof of concept at. So then I see we've got a couple of other questions here. The next is a question around how does SDN and software-defined WAN deal with the carrier-managed routers that might exist at an existing site. So how does it coexist, I guess, with those devices that sit out of those locations? So the simple answer is that it's something that can be deployed over the top of that, that the majority of these solutions are agnostic to the type of underlying transport that's in place. And the underlying transport could be partially a managed MPLS network, for example. It could even be a predefined site-to-site VPN in certain situations where the paths are already defined as to where the traffic can go and the routes are available for the traffic to take. And that just becomes another way of it reaching the endpoints. It's sending it through the already encrypted tunnels, for example. So there's generally a lot of flexibility around adopting those existing technologies. And we've worked out many pilot and proof of concept scenarios where the existing managed MPLS connection was kept, and that includes the managed router that comes with that. And that just becomes one of the WAN paths that can be taken for the traffic to leave that site. And they plugged in a local ISP broadband circuit alongside that then to provide an alternative path. So that type of an approach where you just keep what's in there already and then build this across the top of it is something that can be used to very quickly deliver value into these types of solutions. We've got one last question, which is just around the ease of deploying this type of solution. Is it like a traditional network? So to quickly address that, the short answer is that it's significantly different. The traditional approach of implementing a connection into a site was, long lead times to get the circuit in, get a field engineer out, put in they'll bring the router with them. They'll get on the phone to the central provisioning team to coordinate the local configs and so on. And they would spend typically several hours getting that site up and running. In this type of solution, most of that provisioning work can be done using a templating approach where the device is created in the central orchestration system as a new entity that's going to exist out on the network. And then when the device arrives out of the site, it can typically be shipped to the site with a set of clear instructions. As soon as it's plugged in, it can then contact that central orchestration system, pull down its full configuration, and then become an active device on the network. So we're able to really automate a lot of the deployment of these types of devices to the point where you can eliminate that on-site visit in many cases, and cost reduction that comes with that, but also a time to deployment, and the human risk, human error factor is significantly reduced as well. So I think that's all we've got in terms of questions for today. I'd like to just conclude by saying thank you very much for attending. We've published some of our contact details here, and please feel free to reach out to us if you have any questions or feedback, good or bad, about this type of event. We're always very willing to hear that. And if there's any way we can help develop these types of roadmaps to adopt this technology, we would always be happy to hear that. So thank you very much and have a good day.